So yesterday we were looking at how we can improve building energy conservation by looking at new technologies and building design. And today then we're going to go through and have a little look at our practical of how different building materials are going to impact on the energy conservation of different areas. So we talked yesterday about the fact that space heating, domestic heating, is the biggest domestic use of energy, and that we need to have this equilibrium between the amount of heat going into a building and the amount of heat loss. And these different factors that influence the rate of heat loss, the temperature gradient, the type of material, whether there are any drafts from inside the building through those vents, and again, any of that chilling effect caused by the wind. So based on that, we need to try and work out and control some of these different factors and which ones are the most easily controlled and how we can try and reduce those rates of heat loss. So what I want you to do then, this is our practical activity that we're going to look at. And in particular in this practical, we're going to investigate the heat loss through different building materials. And so in your groups, can you write down a couple of ideas of how you would go about investigating this investigation, this practical? What is the title of your investigation? What kind of variables would you look at? What method would you use? What kind of sampling strategy? How would you actually choose where you are going to do this investigation around the college? What kind of equipment would you use? And are there any hazards or health and safety considerations you need to think about? We now know where we're going to actually do our work, so we need to look at and determine the number of samples required. In order to get the right number of samples, obviously in order to get a mean, we usually just use 3 samples. But is that really true? Is that the true mean for whatever measurement we're trying to look at? So one way of checking that is you keep taking repeat readings, keep calculating a mean, and work out at what point does that mean actually stabilise. And so doing that, you need to take several readings and then draw a scatter graph to work out what is the optimum mean based on the material we've actually got in order to use as a reference point for the rest of our readings. You've all got the equipment here. I've talked you through the health and safety issues with using that kind of equipment. We're going to just use the building here as our resource. We've got a window there and a window there, and obviously you've got some building material there. I want you to conduct this activity. Okay, you've got your graphs there and you've got your tables there as well. Let's work out first up what the mean is that we're going to use in order to do this activity. So come up and grab your bit of equipment. I've got 3, so you can use each of these. And what I've actually done is I have a Excel spreadsheet. I'll plug the data straight into there and then we should get an accurate mean straight away. So you don't have to keep calculating the mean. As we went along, okay, yours is 20.3, 20.3, 20.3, 20.3, 20.2, 20.25, 20.2, 20.2. Okay, so we need to work out, if you plot that on a graph, where would be, how many times did you need to do it to make sure you got the right kind of average. What we would do is then plot that on a graph and you'd work out where would you find the average would be the most appropriate kind of median. So actually ours are very well done, so I'd probably say less than 10, probably about 6 different readings would get that kind of area. So the next thing we need to do then, I'll just talk you through. So we've done that first bit, or we'll go out and do that in a second as well. So again, we need to identify the aspect with the widest variety of different building materials, because that's what we're going to compare. Well, we'll have a little look around the college site and see what these different materials are like. We've got quite a few because we've got a brick building here, rendered there, and then we've got some of the metal facing buildings. We'll see if we can find a wooden building as well. First building type then, you take the infrared thermometer, measure the temperature on the outside of the material. That will be A. Then use your air thermometer to measure the ambient temperature. So what is the temperature like in the air around you at that particular point? That is B. You then need to be able to go into the inside of the building in the same location and do exactly the same. So use the infrared thermometer, record the temperature. Use then the air thermometer to measure the temperature of the ambient surface area in that area. And do that for 3 or 4 different buildings with different materials on them. Then we can calculate the difference between the temperatures of the internal and external surfaces. Then we can actually start to do some graphs and actually plot that kind of data. Okay, let's use that wall. So we've got a brick wall. Can 2 of you stay here and do A and B, and 1 of you come with me and we'll do the inside temperatures as well. Okay? Harry, you come with me and we'll do the inside temperatures. You two stay here. So read the instructions carefully. Okay, we're going to say 10 seconds we said, holding the infrared thermometer. Again, probably at least 10 seconds doing the temperature as well. Okay, so we need somewhere similar aspect. So we're talking about south aspect of one of these other buildings. So we could go to Kingston, or we could go to the study centre. So can you go up to the study centre to this bit sort of here? Come and wave to us from there and just say which side you're going to go to. So Ellen, you go in as well.
I would imagine this side because there's like the TV screen in the way there.
Oh yeah. Pointing at that area, we said 10 seconds, didn't we? 7.1, 7.4.